Till now, we have created an application, we have designed its architecture, and we deployed everything using Terraform. It's time to automate. We're going to do pipelines. Before we continue, let's do some learning. What is a pipeline? A pipeline is a set of instructions that DevOps and cloud engineers do to automate tasks. Basically, you have a lot of different pipelines. From the application build to application testing to deployment phase, you have the infrastructure deployment, you have data pipelines, you do security check, such as SolarCube with pipelines, so you have a range of pipelines that you can do. Our main topic in this video, we are going to do the building and deployment phase of our application, and also a pipeline of building our infrastructure that we use on a previous video to deploy it using Terraform. And the tool that we are going to use is GitHub Actions. Since we are going to do GitHub Actions, let's see how the syntax works. First of all, every GitHub Actions workflow are going to be on .github/workflow. Every action has a name, so you choose them correctly. Every action has an on. On means when you want to trigger it. Basically, you can use manual trigger, you can use a cron job, or in different GitHub events, such as push and pull request or issue, or whatever event there is on GitHub. Every action has jobs, at least one job. Our example here is a build. What is a build job? A job is a set of actions inside that are going to run that make sense together. So a build job is going to have every process inside that builds the image of the application. Now, every job has a run zone. What does this mean? You have tags in it. A run zone means that you specify which runner you want to run it. My example here, it is that we're going to use a Ubuntu latest. As you can see, this is going to run on Ubuntu latest. Now, on run zone, you can either select a GitHub server or your own server. To do that, you need to configure a server, you need to install GitHub runners on that, and you need to start the service. So you can after use that as your own runner, and even in private networks. Now, each job has steps, at least one step. And steps are the actual process that is going to run. Basically, you can run commands on each step, you can run different actions on each step, or either you can run Docker containers. So in case you have all the process it's done by a Docker container, so you can run this Docker container just by specifying its image. So that is all for the syntax that you are going to need for the GitHub Actions. The build pipeline. The build pipeline is going to be the first pipeline that we're going to see. Basically, on the building process, what you're going to do is you have the application source code on GitHub or any other source code repository, such as GitLab or Bitbucket or whatever, and then you're going to build the application. Basically, you're going to encapsulate it. Our application is going to be built on Docker images, like we did on the first two videos of ours, but different use cases have different kind of building processes. One of them can be on building an EC2 image. So you need to utilize other tools, or you need to utilize EC2 image builder. And to do so, you can even use Packer, which is an HashiCorp tool. And the main idea is after you encapsulate it, you save it to an artifactory. An artifactory in our use case is the ACR, so Elastic Container Registry, but you can save it on Docker Hub, or you can save in different kind of cloud vendors. So as we saw the syntax, let's see the steps that we're going to do. We're going to use first of all the Ubuntu latest. The first step, it is the checkout. The checkout, what it does, it copies the code of the application. You do not need to specify any kind of repository since it is going to run on its own repository. Basically, it's going to copy its own code. Since we're going to save it on the ACR, we need to configure the AWS credentials. So what I have already done is that in my repository, I have configured secrets as AWS key ID and AWS secret access key, and the default region is Frankfurt EU Central 1. After that, we have a GitHub action that says login to ACR. Basically, it is pre-built, so you can use it as it is. Now, this is the run command. As you can see, it is a run. What we do here is that we find the repository. Since in our last video we deployed it using Terraform, as you saw it, I applied the suffix to each resources. So in our case, since it was a prefix minus ACR minus a suffix, what this command do is that it describes repositories and it queries the name, the repository name that starts with portfolio minus ACR. So on the back, the suffix is going to be numbers. So since we have only one portfolio minus ACR, it's going to select that one. And what we do here is that we echo the value of the repository as repository to the GitHub output. Why we do that? We do that so from this step we can send this value to other steps and even to other jobs. The reason to that is that when you do this kind of command, let's say when you export foo is equal to bar, let's say, the next step is not going to save that export. Basically, it uses different shell. So in case you use different shell, you're not going to save it. So in case we open the shell and we say export foo is equal to bar, we can echo it at this shell, which is bar. But if we open another shell and we say echo foo, it is not anymore. So what we do, we save every kind of value that we need later on to the GitHub output. And from the GitHub output, what we do? We run the command docker build on the registry, and the registry is taken from this step of get ACR, the repository, and the registry is taken from the login ACR. So basically all those steps have some outputs on it. And the first one is the registry, the second one is the one that we send it to output as the repository, and the image tag is going to be the GitHub SHA, and the last one is going to be the image tag. So basically it's just the ID of the branch, let's say, that this workflow got triggered by. And we have the image tag. The image tag is the hash of the branch on GitHub that triggered this workflow. And the commands that we're going to use are run docker build with the tag of registry, repository, and image. What I have done here is that you take the image tag and you get only the 7 characters of it, the 7 first characters of it. So in case you are going to open the ACR, you're not going to see a long character, so you're not going to see a long hash code of each image, so you're going to see only the 7 first characters of it. And the second command is going to be docker push and the same image. After this build, we see the image on ACR. So let's have a look on how that looks on the GitHub. So we are on GitHub, and let's see what is going to happen if we are going to do a change on the main branch. Let's go to readme. Let's see, just a space, commit changes, update readme directly to main. Now, this is a personal project. In case you are in a corporate, let's say, and you have an application with dev, test, and production phase, you should not do pushes on main directly. Since this is my personal project and I am the only one that works on it, and this is an application that does not need to be fully available, it can do even with a push on main. But in a production environment, you need to separate testing branches, feature branches, and also the main branch. You need to do security enhancement, so no one can push to main only pull requests from the test branch, not from the features. So basically, you do, let's say, a bug fix on a feature branch. You do a pull request on the test branch, from this feature branch to the test branch. After you do that, it's going to trigger the building process of the test image. After that, it's going to deploy this image to the test environment. It's not going to do anything on the production yet. And after the developer sees the test environment, that the bug is fixed, or the new UI is more beautiful, let's say, or the backend application, it works better, then what the developer do is that it creates a pull request from the test branch to the main. And when it does this, it creates the building process of the production image, and then after that it continues with the deployment phase. So never do push on main. Let's see the action. It sets up the job. In here you can see what kind of runner and what kind of dependencies it downloads. Okay, the first one is the checkout that we did on the GitHub YAML file. So basically it copies the repository Ronaldo Nazo / can do it, because you can also do it. And yeah, it copies the code. The second point is configuring AWS credentials. On the settings, we can see on the secrets, the action, we can see that I have already configured access key ID, secret access key, and also the backend S3 bucket that we're going to see later. Let's see the next step in here. So configuring AWS credentials, we are configuring the ACR. If you can see, we got the registry and we do the get ACR. It runs those commands and it sends the repository to the GitHub. Now, the last step, we can see the environment variables. If you can see, the repository is the portfolio ACR and the suffix, so it finds it correctly and it is only one. The registry is the same as the step before, and the image tag is the same as the hash of main branch. We do the building process, so it copies the base image, it does all the running of the dependencies, and after that it pushes to the ACR. So as you can see, it is pushed correctly, and in the end it does the post actions of every action that it did before. So that was the building process. And if we go to the AWS console, so we are on the ACR, this is our repository, and as you can see, just right now the image got pushed. If we want to check the hash of the main branch, it is DCD, and it is the same DCD F27. So it is the same. So the building process went successfully. It's time to deploy that image. We built the image, we pushed it to ACR. Now, you can use different kind of approaches. My approach is simple. AWS is such a beautiful cloud that you can use event triggers for everything. Basically, when you push an image to ACR, you can trigger an event on it, and you can use this event to trigger lambdas. So my idea was that you push the image to ACR, you trigger a lambda, and what the lambda does, it does the deployment phase. It does not matter where it is deployed, you can use it, and since you're using a lambda, you can code it, and since you can code it, you can use whatever library that there is to do whatever you want. What I have done, I have used Boto3 to integrate Python with AWS, and since we're going to deploy it on another Lambda, then we can use Boto3. What do? We get the event, we get the repository name, we get the image digest, so basically it's the hash of the image. We get the region, in case we need it, but we can even hard code it since we do everything on EU Central 1. Now we get the account ID. This is to create the image URI. So it uses the account ID, the region, the repository name, and also the image digest. Now we create the Lambda client on the same region that the ACR is. And what we do is this action of update function code. So the update function code, you specify the function name of the Lambda that you're going to update and the image URI. So since the image URI is the image that we just pushed, after this update function code, it's going to change the application code. So it's going to have the new application that we just committed on main branch. And that is all for the deployment. Let's see how the Lambda managed to deploy it. So we go to Lambda and we can also open our portfolio. As you can see, before 15 minutes, it was an update on portfolio Lambda, which was our Lambda, and portfolio image deployer. So we have this portfolio image deployer that we built. So the event bridge, basically it gets triggered whenever a source it is AWS ACR of ACR image action and on actions of push. Whenever they succeed, and the repository is going to be the name of the repository. Let's see the logs. As you can see, the application code, it has the URI of the new image that got pushed. So as you can see, FBB, it is the same as the digest of the last image that we just built. So it is the FBB, so it is deployed correctly. And if we refresh it, it's going to be the same because what we changed was the README. And on the logs, as we can see, the Lambda printed that the function image is updated correctly, and also with the response metadata. So that was the deployment phase. You can use whatever you want. If you have, let's say, a Kubernetes cluster, you can even use Python with Kubernetes client, login using AWS update kubeconfig, and then change the image of a deployment there. And this kind of approach, the benefit of it is very simple to implement, and it is very, very fast. So in case you're using Helm charts, let's say, and GitOps using Argo CD, that basically it's going to take like 5 minutes after you push the image to deploy the new image. Lambda, 5 seconds. So you choose what you want, but Lambda, by far, for me, for now, it is the fastest deployer that I have tested. Let's deploy some infrastructure using pipelines. On the last video, we deployed our infrastructure using Terraform. Terraform, it is the code. As code, you can automate it and you can do pipelines on it. So you do not go every time there is a change on your infrastructure or you add a new service to go and run Terraform init, plan, apply. So you make a pipeline for that. What I have done is that I've created a workflow for plan, apply, and also you can do for destroy, but I have not done that. Since destroy, it's kind of tricky and you really need a good reason to have a destroy workflow. I have not done that because destroyment can be manually since it is only one. So let's see how plan works. Basically, to deploy infrastructure, you need to be cautious. And for that, Terraform has plan. So what we do, we separate plan and apply. I have also done pipelines doing the same, but since this is a private repository, my idea cannot work with that, but in the future I'm going to do new pipelines that can integrate plan and apply in the same GitHub action. Let's see how plan works. Basically, it's going to be triggered on pull request. and the paths that it's going to be triggered from, it's going to be only the terraform. So every kind of file that is going to change on terraform folder, it's going to trigger a plan, but also it is going to be only pull requests that are going to be on the branch main. So in case you have a feature branch and you're going to do a pull request on test, this workflow is not going to run. Now, as you can see, the website static ***. I have done this because on the website, on the static, every kind of those folders, they are part of the S3 objects. So in case something of those changes or something of those gets added, we need, or let's say the image of ourselves, I want to change the image, let's say, I change it right there, and Terraform is going to run. It's going to copy all this folder to the S3. So it does the sync process as we saw last video. And that is the reason why on the website static, it's going to run infrastructure. But even though this is part of the website folder. And on the website folder itself, as you have seen, is that I have separated it. So it ignores everything that happens on Terraform and website static. We do not care of it because we do not build from it. We do not use that directly to our web application source code. We take that from the S3 bucket. So it is an infrastructure partition. We specify environments, so since we are on Terraform automation, we do not need inputs from a user. So we do the tf in automation as true. We need to specify logs. So every Terraform command that we do, it's going to generate logs. Since we are on a pipeline, we need to find everything that goes wrong with our pipeline, so we specify it as tf log warn. The directory is going to be Terraform. This directory specifies where we're going to run all of our commands. So we have the jobs, and the first job is going to be plan. Defaults, it runs on working directory on Terraform, inside of Terraform. What it does there? It does a plan. So it's going to use the Ubuntu latest. It's going to use the Ubuntu latest. It's going to copy the source code of the repository. It's going to configure credentials from the secrets that I just showed you. And also it's going to do Terraform init. Now, Terraform init. Since we are going to run it on a runner, we don't know where, we need to save the state file of the infrastructure. To do that, we need to configure the backend configuration. And the backend configuration, in case you're separating test environment and prod environment and you specify different runners, let's say, or you want to save the test environment on the test file saving buckets of Terraform and the prod environment on the prod Terraform state file buckets, you can use this configuration of Terraform init specifying backend configurations. So the bucket is going to be from secrets, backend, S3 bucket. In case this is also used for security, privacy. So in case someone opens your workflow, it will see on the backend S3 bucket as stars. So he will not be able to see what kind of where did you save this Terraform state file, because Terraform state file is very valuable. It holds every information that you deployed. So every kind of database password, the SSH keys and everything are going to be stored on the Terraform state file. So you need to keep that secret. On the iPortfolio, Terraform tf state is going to be the key. Now we do a validation and also we plan it. We plan it and we specify it out as tf plan. Now we do a show of tf plan just in case we need it later and we can find it on the artifact of the GitHub. And the last action is upload artifact. So in case you want after 90 days, let's say, you want to check what kind of plan did you do, you can open the Artifactory of GitHub and you can see this plan. All of this does the plan. You see what went wrong with your infrastructure or what went great, and you either merge the pull request or you deny it. Terraform apply. It has its own workflow. Basically, it's the same as Terraform plan. It just changes on the way it gets triggered. It was on pull request. This one is on push, on branch main, on the same folders. Same configurations, and the change is only on the last part of Terraform apply with the flag auto approve, so it does not wait for yes or no if you want to approve it or not. Let's see how those both looks on GitHub while running. Before we go, I've already done a change on our Terraform resources. So since we deployed the Lambda that is going to deploy our application with the code that we just saw on Python, I have created this file of deployment pipeline.tf, which what it does, it creates a role for the new Lambda deployer. Basically, it's going to have access on Lambda update function code for the Lambda that we deployed last video, or our main Lambda. It has access on the create log group, logs, and also the events. We create the CloudWatch event rule. Basically, as we saw, it was on AWS ACR, on pushes, on this repository that we built last video. What it does is that from the GitHub workflow deploy.py, it creates a zip file of the application. So it's going to be deploy.zip. This deploy.zip, the Lambda is going to use as the code itself. So runtime is Python 3.12, and I did not mention this. Basically, on the environment, you can also replicate this for your Lambda, and by specifying the environment variables. Environment variables, I specified the Lambda function name. So it's going to be the target Lambda that you want to deploy this image. And the target Lambda is the Lambda that we have our main application. So even on the deploy, this was the part that it gets the environment of Lambda function name. And this Lambda function name is the name of the Lambda that is going to update the code. We have the CloudWatch event target that this Lambda is going to be the target for the event that we just created, and also a Lambda permission that allows this event to invoke our Lambda. All of this was the new change that I also did. So let's see and trigger a new push. So we go just to a test, and then we add this change to test. So let's say a small bug fix. We deploy it on test environment. Yeah. So for the moment, it has not done anything. What we do is create and do a pull request. On the branch main, we approve it and a pipeline has started. As you can see from the name, it is Terraform plan. This is the name of the actions. This is why you need to specify different kind of names. So in case something is running, you can understand which action is running. On the plan, we see it does the Terraform init. It initializes the backend. So the beauty of GitHub runners is that it has every tool that you might need. So in case you need Docker, they have it. In case you need Terraform, they have it. Kubernetes, they have it. AWS CLI, Azure CLI, Google Cloud Platform CLI, they have it all. In fact, it was a couple of days ago that I was reading about it, and I saw that it has a broad range of tools inside of every runner. So You do not need to install or use steps to configure, let's say, Terraform. So before they didn't have it, so you need to use, let's say, the configurations to install the Terraform on the runner itself, but now they have it all, so you can use whatever you want. I will also find the link, and you can find the link on the description below. Now let's see how the workflow went. Basically, it requests to plan only one resource, and this resource is the resource Docker image. Why is this Docker image? Because Docker image as a resource needs to create an image on the host that is running the Terraform. And since this is a GitHub runner, basically we do not know if they have this image of Ronaldo the Pirate Lambda image. So every time we run it, they are going to install this resource. Now we do a Terraform show as creating a tfplan.txt and also upgrading the artifact. If you want the artifact to see it after 90 days, let's say, you can download it and you can see what kind of plan went. So since the plan finished and we are happy with it, we don't have any change, let's say, or if we had a change that we approve, then we can merge pull request. Merge request started another action. It was the Terraform apply. Since we specified that it's going to be triggered on push events on main branch, it started. It does the same: Terraform init, Terraform validate, and apply. As the plan, it's going to create this Docker image on the host itself, and after that it's going to say that everything is fine. In the output, it's our website. We deployed pipelines for building, deployment of our application, and also plan and apply of Terraform infrastructure provisioning. We can go even more by creating pipelines for security checks whenever someone pushes code to GitHub, and based on the application we can also add other pipelines, but for now those four are just fine. Now technology advances every time. You can deploy your application in different kind of approaches, in different kind of cloud providers or different kind of environments. In case you're going to deploy on EC2, you need to change your pipeline. In case you're going to deploy in Kubernetes, you're going to change the way you deploy it and how you manage it later. But the main idea stays the same. You need to create pipelines. You need to automate your work. You need to make time more efficient. And remember, a good DevOps is someone who automates his work.